in regression, we refer to the difference between the estimated value from our model and the value that actually happened as our residual, right? This residual is the part that's left over from our model, the part that we can't predict. In an ideal world, we want that part that we can't predict just to be some random noise, right? Just to be stuff that's not a function of other things. So let's look at a simple example. Here we have a two-variable setting where we've hypothesized a relationship between y and x. We've done a scatter plot of y as a function of x. We've overlaid our regression equation on that scatter plot. And so that regression equation represents our prediction, and we can see the differences between that prediction and a series of our data points. And we see that that difference is changing as the attribute increases, right? At one level, the prediction is less than our sample. At another range, we flip to be our estimated value greater than the sample, and then we go back to being less than the sample for higher values of our attribute. So the residual seems to be displaying some kind of pattern or function of, in this case, the underlying attribute. So we can look at those residuals in a residual plot. And what a residual plot is simply just those differences, but displayed as a function of the predicted y, right? So it makes the visualization of those residuals much cleaner. And so now that pattern that we talked about is much more nascent, much more obvious. And so if we see that pattern, then that tells us perhaps we've missed something, that there's something else going on. And usually what that something else going on is that we've modeled a nonlinear relationship as a linear one, right? So we have a curve, we've tried to fit a line to that curve, and as a result of that, these residuals or differences are a function of that underlying attribute. So let's look at a multiple regression example. So refocus on those attributes, right? So if we have a multiple regression example where we have two attributes, and we run our regression and generate that prediction and look at those residuals, initially as a function of our predicted y, we see that there's a pattern, right? My ability to make an estimate is different for different values of what I'm trying to predict, right? So that tells us that there's some potential nonlinearities happening. It doesn't tell us what's driving those nonlinearities. So we dig deeper and look at those residuals now as a function of the individual attributes. And so for our first attribute, when we look at those residuals, they just seem to be sort of scattered loosely in and around 0 for different values of the attribute, right? We don't necessarily see any relationship between the residuals and the attribute itself. Whereas we look at our other attribute, we see that the residuals change, right? They go from these positive numbers to negative numbers to positive numbers for different values of the attribute. And so knowing the value of the attribute would tell us something about the residuals, i.e. something about our ability to make an estimate for y. So that informs us that there's some nonlinearity happening between that attribute and our dependent variable. So we would address that nonlinearity by doing a transform for this attribute, but we would leave the other attribute alone because it is not displaying any nonlinearities with our predicted value.